Dear students, welcome to my YouTube channel PCM Academy. We are in a lecture series of quantum mechanics, and as you know, we have finished our mathematical tools of quantum mechanics, and now we will move to the most important part of this section, that is postulates of quantum mechanics. And the whole quantum mechanics is based on 5 postulates, so we will discuss one by one. But before going to that part, let me tell you what is the approach of studying a system, that is a system of particles. If you talk about quantum mechanics, or it may be classical mechanics, so these are all about study of the system of particles. So maybe it is a single particle, maybe it is a number of particle system. But the basic thing about this is what we are actually want to study in this course, in this kinds of course, that is the studying of the system, that is the dynamics of the system. Actually we want to predict the future path and the motion of the dynamics of the particle. So but there are different kinds of particle if you talk about with respect to their mass, their inertia. So the particles which have very low inertia, we discussed the mechanics of that particle in quantum physics, and the particle which have large inertia we have discussed in classical physics. So basically if you talk about the mechanics, then the two parts, one is classical mechanics and another is quantum mechanics. The basic difference is the property, the inherent nature, or you can say the inertia of the particle. So let me tell you the approach, how we approach to study a system. Maybe it is a large inertia system or maybe it is a low inertia system, but the approach is same. Maybe the law involving the system is different, but the approach is same everywhere. Okay, so let me tell you that first. So if you talk about if you talk about mechanics is all about study of system of particle. So if you talk about mechanics, then what we will do in mechanics, this is actually study of system of particle, study of system of particles. But if you talk about classical mechanics, if you talk about classical mechanics, then here what we will do, we will discuss or we will study about the system of particle, but the inertia of the particle is large. So large inertia particle, large inertia particle. Okay, but if you talk about quantum mechanics, if you talk about quantum mechanics, then what we will discuss here, or we will study about the low inertia particle. That means mass of the particle is very less, something like electron, proton, low inertia particle. Okay, so low inertia particle. So now let me tell you what is the approach of studying the system. Maybe it is in classical mechanics or maybe it is in quantum mechanics. So you know, you have already studied about classical mechanics. So what we have to do first we have to define the state of the system. So first what we have to do, we have to define the system at t is equal to 0 basically. So state of the system, first we have to define the state of the system, and also we have to know about the initial position and momentum of the system. So we have to know about the initial position and momentum of the system. That means initial position and velocity, actually position and momentum of the system, and then what you have to do, this is actually the statics of the system. You know, this is actually called the statics of the system. Okay, initial position and momentum at t is equal to 0, this is called statics. Now you have to study about the dynamics of the system, that is we have to know under which law this system is evolved, or we have to know about the basic law of force actually, that is here Newton's law of motion in classical mechanics, that is the dynamics of the system, you can say how the system evolved with time. So that will be dynamics of the system, dynamics of the system. Okay, and in dynamics of the system we will use some law, something like in classical mechanics we use Newton's laws of motion, or in another way we can also study, that is called Lagrangian and Hamiltonian equation. So that is the advanced course of classical mechanics that we will discuss later on in the course of classical mechanics. Okay, so Newton's laws of motion and Lagrangian and Hamiltonian mechanics in Hamiltonian equation, you can see. So we will use this. Okay, but if you talk about quantum mechanics, the approach is same. We have to first define the state of the system, that is we have to know about the statics of the system. So state of the system, we have to study the state of the system, but the problem here is that we can't predict the initial position and momentum simultaneously. That is, here is an uncertainty in position and momentum, but here there is no uncertainty, so we can easily define the initial position and momentum of the system. So that's why here we need a probabilistic approach by using the wave function psi. So here state of the system, means actually the wave function psi, that is the k factor psi, we have discussed already in mathematical tools. Okay, so we have to first define the state of the system, that is the static of the system, you can say, or you can say that the initial instead of initial position and momentum we have to choose different kinds of things, that is the operator formalism, that is observables. Okay, so physical measurable quantity is replaced by observable. So we will see these kinds of things. So basically we can say this is the statics of the system. The method is same, but the approach is same, but the law involves and the, you can say here is the definite thing we will use in classical mechanics, but here always we will discuss about the indeterministic thing, something like this. Okay, so state of the system, and then obviously we will study about the initial state, that is the statics of the system, and at the last time we have to discuss dynamics also, but here we will use basically Schrodinger wave equation. But I think you do not have very clear about this, the approach of the quantum mechanics, but you have a clear idea about the classical mechanics, but you have a little these things are not very easy, you feel, but this will be sorted out when we will discuss about the postulates of quantum mechanics. Basically postulates are made to discuss this approach. Okay, in 5 postulates we will discuss basically this kinds of approach. Okay.